Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. Firstly, thank you very much for this opportunity to share our research result in 6th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering ICIMECE 2020. At the moment, I would like to present our research result about the effect of bellmouth radius and venturi restrictor length on the power and torque of the BM9 engine. I'm Fauzun and my research colleague Cahyo Wibi Yogiswara. We are from Universitas Gadjah Mada. Introduction of this research as follows. 1. Formula Student SAE Japan is an international class formula car competition held by the Japan Society of Automotive Engineers annually. Second, students are required to be able to design and manufacture formula car according to the regulatory standard of SAE International. 3. One of the improvements in the car performance to get maximum result is to modify the air intake. Number 4, modification of air intake must based on SAE rules, which are air intake must has single throttle body and must has a restrictor located after throttle body with maximum diameter 20 mm. And number 5, this restrictor at air intake made power and torque produced by engine decrease from the engine specification in standard condition. There are two objectives of this research. First, the possible way to increase power and torque produced by engine are modify the bellmouth radius and the length of restrictor with venturi shape. Second, the objective of this research study are to know the effect of bellmouth radius and venturi restrictor length at air intake on the power and torque produced by KTM 450 SXF engine used by Bimasakti UGM 9th generation. This picture shows air intake system. The right picture shows about air intake system of BM8 or air intake used in previous years. This air intake system is used for validation of simulation method. In the left picture, show that air intake system of BM9 or air intake used in current years. This air intake system is used for simulation. The air intake system consists air filter, bellmouth, throttle body, restrictor, plenum, and intake runner. This table shows KTM 450 SXF engine specification used in this research. Engine type single cylinder, displacement 449 cc, cycle 4-stroke, bore 95 mm, stroke 63.4 mm, compression ratio 12.8, valve configuration single, number of speed 4. This table shows about powertrain system wall temperature setting. First column show about part. Second column describe about material use. Third column about wall temperature setting. This picture show a schematic of the modeling in the Ricardo Wave simulation. Start from intake ambient, bellmouth, throttle. In this component we can set throttle angle and restrictor, throttle, plenum, intake manifold. Before intake manifold, any injector, and after that intake port, and this component we can set engine RPM and enter the cylinder and exhaust port, exhaust manifold, header, muffler port, muffler, tailpipe, and the last exhaust ambient. Validation of simulation method is done by comparing data of power and torque Bimasakti UGM car 8th generation based on well dynamometer test or dyno test result to Ricardo Wave simulation result. In this graph, we can show the dyno test. Any two curve, power curve and torque curve. Value of power, we can use number in vertical axis in left side, torque in right side. This graph show validation. This graph show simulation result is used to validation. The right graph tell about torque versus engine speed, and left graph tell about brake power versus engine speed. The graph between the dyno test and simulation result are similar and indicate that the simulation method used in this study is valid. This table shows several result engine speed. Based on the table, we can know that the difference in the result between dyno test and simulation Ricardo wave of BMH is under 5%. So the simulation method used in this research is valid. This is a design variations. Design variation dimension for bellmouth radius we set 30 mm and 15 mm. For divergent length of venturi 95 mm, 75 mm, 55 mm. Whereas fixed dimension, the throttle body diameter 36 mm, outlet diameter of venturi restrictor 40 mm, and convergent length of venturi 25 mm. Configuration of the design we can see in this picture. Simulation graph result. This slide shows simulation result for brake power value versus engine speed and brake torque versus engine speed. We can see for all variation the result almost close, but we can see design number 3 is always on top position at the power graph or torque graph pattern with the peak power value 39.4 HP at 9300 rpm and peak torque value of 29.38 Newton meter at 9000 rpm. This table tell about peak power and peak torque for each design number. We can see that the highest value of peak power and peak torque on design number 3, while the lowest value of peak power and peak torque on design number 7, and design number 5 is on middle result. The following describe about Ansys Fluent simulation. We didn't simulate all variation. We just take 3 samples of design to be simulated in Ansys Fluent, which are the best design number 3, middle design number 5, and worst design number 7. Ansys Fluent used to prove the power and torque result based on pressure loss data, where pressure loss means inlet pressure minus outlet pressure. And in Ansys Fluent, we set up for viscous model K epsilon, boundary condition for inlet total pressure at 1 atmosphere, and outlet mass flow rate is equal 0.0703 kg per second. The Ansys Fluent simulation result we can see in the table. Design number 3 produced the lowest pressure loss value compared to design number 5 and design number 7. The data also matched the result of peak power and peak torque value based on Ricardo Wave simulation before. This result indicates that greater bellmouth radius and longer divergent length of the venturi restrictor can produce higher value of peak power and peak torque with lower value of pressure loss. This picture shows about contour of pressure. Contour of pressure design number 3, design number 5, and design number 7. The contour tells same like explanation before. In the facts, we can see contour of pressure design number 3 give the minimum pressure loss. So, based on the research result, we can withdraw the conclusion as follows. Number 1, bellmouth can increase the peak power and peak torque values, which is proven by the result between design number 3 and design number 7. Number 2, the best design variation in this research is bellmouth design with 13 mm of radius and venturi restrictor design with 95 mm of divergent length that produce peak power of 37.94 HP at 9,300 RPM and peak torque of 29.38 Nm at 9,000 RPM. Design number 3 produced lowest pressure loss of 4,713 Pascal in the restrictor. I think that's all. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.